Hi, welcome everyone to our session on innovative medical device engineering education at KGI. My name is Anna Hickerson. I'm a professor here at KGI, and I've worked at the Institute for 15 years. And over the last couple years, we've just launched a new program, Masters of Science in Medical Device Engineering. And I wanted to share with you about that program, what the students are experiencing, kind of our motivation behind it, and hopefully help educate you to hire our students if that is something that is in your ability. So smack in the middle there is myself in the green shirt, and the 5 students that you see here are our first and second class of students. They have 2 have recently graduated, and they came into the program from a pre-med, so they're off to medical school. The next 3 that you see are from around the US and international, and they are very eager to start careers in medical devices. So let me present to you about the education and the program itself. And I'll sort of interweave in there for you the motivations and what kind of feedback we got that helped us create this program. So these are, as a student, of course, the students will have the opportunity to interact with patients and healthcare providers to gain a true understanding of the clinical setting and user needs. So user needs, as you may know, has been a very important part of med devices, especially recently. And I felt, and the feedback that I got from professionals was that new graduates, just especially engineers, had very little experience in this area. So I'm going to talk about a course that lets them really get into the nitty-gritty of this part. Learn and apply industry practices to develop and manufacture viable medical devices. So in addition to some traditional style engineering courses, KGI as a whole is very industry focused. Our first program is actually the Master of Business and Science, and we focus on innovation. So not just innovating our education, but having innovators as faculty and innovators as students. And part of the way we do that is to have the students work in teams with industry sponsors to solve real world problems. So we have many opportunities for people to connect with KGI if that's something you're interested in. And I'll talk about our capstone project as well, which is a key component to this education. So starting at the clinical experience for engineers, this is the way the students get to interact with patients and providers. They are actually sent to a clinical site, this year excluded because of obvious reasons, but the previous year they had gone to Cascalina Hospital to the occupational therapy department and worked in the assistive technology lab. And then once a week, they would meet back with a faculty member and go over things that they identified that were challenging points, either for the patient or workflow issues, and then analyze that to come up with a set of user needs or a proper engineering problem statement. And they had to keep their hands off from solving anything, which is very tempting for most engineering folks. Some of the work they do in our medical and assistive device lab. This is a really fun space that has a lot of tables just set up in, they're not round, they're square, I guess, square tables set around for people to work in groups. We have a lot of our fabrication equipment in there. It's accessible to the students 24/7. So they have various types of 3D printers, laser cutters, vacuum forming equipment, imaging technology. They can do all of their prototyping for classes as well as practicing for group projects. And then they're actually allowed to do personal projects in there as well. And my philosophy behind that is the more you tinker around and create stuff that gets you excited, the better you get at it. So this is, again, our medical and assistive device lab, and we're super grateful to the Fletcher Jones Foundation for giving us a generous grant to fund the equipment. At the end of our program, or in the second year, the students participate in their capstone experience, and we call this the Team Masters Project. Several of the degree programs at KGI participate in this. It is a project that gets sponsored by a company, in the case of our students, a medical device company, and that project lasts for the full year or academic calendar. There's teams of 4 to 5 students, a faculty advisor, and a corporate liaison all work together on a real problem statement. The team acts like a consulting group, so they come up with a project plan and milestones, agree with the sponsoring company, and then have weekly updates and meetings. And the types of things that the students do, they can do user experience research, they can do some designing and prototyping. We do actually teach about manufacturing technology, so developing manufacturing strategies. Depending on the project, we can even address regulatory issues. So our students are very well informed to do a true consulting type project, and that gives them a heads up and the real experience that then helps them land a good job, which is what we want for them. So coming back to the curriculum as a whole, I used to initially teach product development, so that's where my heart is. But obviously the process is much larger from start to finish to get a user need all the way down to a manufacturable, regulated, true product out on the market. So we built a larger curriculum around this. First starting with identifying those needs. And so we do have that clinical experience class that I already talked about. We have a human factors type of course that deals with user interfaces and how people interact. On the sort of product development window, there's a bit. So we have, I guess, on the design, mechanical design stages of it. I teach a CAD class. We teach it in SolidWorks and Onshape. Our students are able to do other CAD programs like Inventor or otherwise. And a really great prototyping class where students start from things like very low-tech prototyping, cutting out stuff and using markers just to demonstrate and conceptualize ideas in order to be able to properly share it, all the way up to various prototyping techniques that includes the 3D printers, but is much larger in scope, including the laser cutting, vacuum forming. And then they move on to another course on production methods. So this is the full scale quality type measurements. How do you do injection molding or sheet forming and things of that nature? So to scale up those products. There's a general product development course that I continue to teach. That one goes all from start to finish with all the documentation, starting at the user needs to getting a functionable, testable prototype. At the end, they submit a design master record to me for their final presentation. We teach in vitro diagnostics, medical devices. A lot of our faculty are really interested in vitro diagnostics. That's their main research area, so that's a definite strength of KGI. And then KGI is super into business and understanding that you can't just have a design with no business around it. So our students do take an intro to business of bioscience course, an operations course, and then they have an elective that they have to take in business. That might be marketing, that might be supply chain, something of that nature. There's also a quality control class, and they take regulatory classes and then ethics. So this is the idea is that they get the full spread start to finish and really understand all the roles in the company, and then for themselves focusing on the engineering roles and not just the research, not just R&D, but also understand the testing and the manufacturing and things of that nature. Here's some of our faculty. I have it split up. We have an OT, we have people who teach career services, business, diagnostics. That's myself wearing the same shirt. This is my dress shirt, so please giggle if you feel like it. And then some other folks that are doing great stuff. These are like, as I said, a lot of innovators at KGI. I'd like to point out Kiana Ron here. She's the founder of Cardia Bio and just recently got awarded a fantastic NSF award, career award. We have a former alum teaching a class. We have and 2 industry folks who spent many, many years in the industry, so they came back to share their real knowledge as it was actually applied in the industry to the students. So it's less theoretical and more applicable. Okay, so what makes this program special? Our industry relationships and opportunities. This includes the capstone project, which I described, but there are many other ways to have relationships with our students and vice versa. We have many speaker series, so our corporate relations office would be more than happy to connect with you. We have unsponsored projects that are part of other classes that are not quite as large as that capstone. And it really gives a chance for our students to interact. Our advisory council is largely made up of industry people, so that helps us keep that tie and understanding of what the real needs are right now in the industry. The experience in a clinical setting, that's very unique to an engineering program. I know there are a few others, but for us, this was a really important point that they get to go to an actual practice site. It is taught by our program director of occupational therapy. So we have we are launching a occupational therapy program. And once that's launched and we have students, we're really hoping to have interactive classes where the occupational therapy students have a much better in-depth understanding of their patients. Our students can interconnect and then come up with solutions that truly meet the need, as opposed to gimmicky solutions without needs. Inclusion of manufacturing quality and operations practices. So as I said, the folks teaching these are people who were practicing in the industry for many years, and so they are very qualified to do that. Business and regulatory elective offerings. Because of the integration with all our other programs, such as the Master of Business and Science, we have faculty that can teach those business classes, faculty that teach regulatory, and come with that experience as well. And then the team-based projects. So as opposed to doing regular homework sets like maybe an undergrad program might have, every single class has some kind of team-based project. Some of them are majority team-based projects. People don't work in a vacuum, so we don't have them practice at school in a vacuum on their own. You know, they're allowed to go out there and ask for help and get assistance and then create something really special. So that's what makes our program special. As far as other opportunities that you could help us out, or we could connect and help you out, we do have a professional development course for the students where they get a lot of heads up on how to do their cover letters, interviewing practices, and so forth. And again, participating in industry events. So I would love to connect with folks that want to come and share their experiences at any industry event. Nowadays, it's easier than ever since we're all on Zoom anyway. You can just lend out 30 minutes, an hour of your time, share your experiences, and I guarantee you there will be students who come and are excited to hear what that is like. Our students are also searching for both full-time positions and summer internships. So if you have any kind of summer internships available to students that have this kind of training, again, reach out to myself and I will connect you to the right people and to the right students. If you're skeptical, come and send me an email and I'll help explain it one-on-one with you. So to contact me, just use my email, Anna_Hickerson@kgi.edu. We have two websites, one for our master's program, which is the one I described here. That's the bottom link, kgi.edu/MSMDE. That stands for Master of Science in Med Device Engineering. And then we also have a boot camp that's for undergrads. So if you happen to be an undergrad or you know someone that is interested in trying out this career without necessarily committing yet to a full master's degree, this is a really fun 2-week online program. They do group projects over those 2 weeks, and they get an introduction to all the topics that I discussed in the program itself. So with that, I want to thank you for listening and joining in on this recorded session, and feel free to reach out. Thank you very much.